And just let's hope the camera didn't hear any of what I just
I
said.
don't understand how to do.
I didn't do the back half.
Yeah, this and that.
Ah, why don't you want to stay? Oh, won't you stay with me? Yeah, people are just going to hear me
Like
singing
an
at the
explanation
moment.
though, so that was like.
No. What?
Chase, did
You
you
want
understand how to do number 4?
Actually, can we do it tomorrow? Today I got a lot to do in a short class, so.
Yeah, you just do the mean.
Is that all right? Oh, yeah.
The backside.
This is just a verbal explanation though.
No, one you would explain to student's error. I didn't know what student's error was. Homework questions in the backside's existence.
All right, we should just get rolling, I guess.
Yeah.
We got a lot to do, so. Go.
4 and
The
6.
backside.
You know how to do it.
Do we?
It was like, yeah.
Do we really?
It was like, okay, so minutes, but then what about the meters?
You give it to Rachel.
Before I go home.
Four's the minutes thing, is that the issue
Oh, don't
there?
hurt my gloves.
You have options, you have many options on 4.
Did you cut the fingers off?
One option is
Don't hurt my babies.
basically treat 4 o'clock as 0. So in that case, your mean would be 30. And then this would be 45. This would be 60. This would be negative 15. That's one option. Another option is do it purely by decimal. So count that as 4.5. Right? 4:30 would be half past the hour, so 4.5. This would be 4.25. This would be 4.75. This would be 3.75. Right? Missed you in Ec Lab. I signed you up and everything. And Karma, we missed you too. Oh.
Yeah, she had a doctor's appointment.
So anyway, that's another one. So there are many options as to how you can do that. Yep.
Could you convert every time to minutes?
You can convert every time to minutes, which would make this 270. Is that what you're saying?
Yeah.
Yeah, you could do 270, which would make that 285, which would make that 300. Yep, that's totally fine. All of those you should be getting the same probabilities, the same answers. So, is that good enough for 4 in terms of what to do?
Yeah.
Okay. Orchard, apples, bags, 5 pounds each is mean. When full bags weigh 5 pounds each, contain a whole number of apples. Weights are normally distributed with a mean of 5 and a standard deviation of 0.25. Come on, go the other way. Smaller. There we go. There we go, that's good. The inspector weighs each bag and rejects all bags that weigh less than 5 pounds. Describe the shape of the distribution of weights in bags that are not rejected. Talk to me. Before you start talking about the shape, tell me about the graph. Tell me the original graph. What type of a graph does it look like? It's a normal curve. Okay? But then we are going to get rid of The entire lower half. So the entire left half of the graph is gone. So all we have then
So it's skewed left.
is the right half of the graph, correct? Means that it looks like that. Okay, so tell me about the shape. Skewed to the right. Yeah. Does that make sense? Questions there? Others? The student's response was, well, okay, I'll read it. Describe the relationship between the area under a normal curve for all x values less than a and the area under the normal curve for all x values greater than a. The student's response was both areas are 0.5 because the curve is symmetric. Is that statement correct? It could be. Is that what somebody said? When would it be correct? When A is the mean. That is perfect. When A is the mean, that statement's perfect. That statement is great. So therefore, the error is, what is A? We don't know. So the error is, that statement is only correct if A is the mean. Yeah, that would be the error. So what if I asked you, describe the relationship between the area under a normal curve for all x values less than A and the area under the normal curve for all x values greater than A? What if I asked you to describe that relationship? Would you? Yes, okay, good enough. Next question. I'm just kidding. What is the relationship?
Both sides are adding to 1. Yeah, that.
The area less than A and plus the area right of A must add up to be 1. Or, if you know the area to the left of A, the area to the right of A is 1 minus that area. Yep, perfect. So if you think about it, the chart that we use, remember that says, up the top it says represents represents the area of the curve to the left of the z-score. So how would you find the area of the curve to the right of the z-score? 1 minus that number that you get. So, does that make sense? Cool. Yes, ma'am.
Lasers.
You may. Good luck.
Thank you.
Okay, that's it? All right. So, for all of you who are trying to... This is not me. What I'm supposed to take them away. She did not. She did it here. We are not collecting homework today. Everybody's like, oh my God, I gotta write it down quick. Yeah, by the way, for everybody that comes into class and tries to quick write everything down and get homework done, stuff like that, okay, just a reminder as to the word. The word is, let me remember this, homework. Which implies that it should be done
At home.
at home. Okay? It is not beginning of classwork. Capiche? Yes, sir.
That works.
Rachel gets it. Rachel's the star. All right, so we are going to get rocking on the new stuff. Okay? I believe it's the last day of new stuff.
What? Did you say California rules are gross?
So Katie had a game yesterday, a school game, playing the second best team. Katie's 12. She was playing a team that had a club pitcher that turned 14 years old. She was pretty solid. So Katie's team gave up 6 runs in the first, which is the maximum they're allowed to give up in school ball. And then they were going to give up 6 runs in the second and 6 runs in the third, and that was going to be the end of the game. And it was. But on our team, Katie was the leadoff hitter. So she's the first one to bat the game. And she gets up against this club pitcher and hits an absolute rocket. Line drive over the shortstop's head, goes to the fence. And it was baseball and softball players, you know the crack of the bats these days, the not ceramic, what's the word I want? Composite, thank you, dear God, I can't. The composite bats, it's a crack. This was a loud crack, it just took off. So she gets a triple. And then she delay steals home. So they score a run. The next kid for her team struck out, the next one struck out, the next one struck out, the next inning, strikeout, 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 the third inning, strikeout, strikeout, strikeout.
My God.
Katie was on deck when the game ended. I said, did you want to hit again? She's like, yeah. So anyway, we kind of knew what the result was going to be. But proud dad was there going,
Yes, she scored a run.
she showed that she can certainly compete at that level, and that was pretty cool. Anyway, okay, here we go. This will be questionable as to whether I can get done, so I'm going to try to keep the pace rolling a little bit, okay? Data was collected about the first 50 people to join a new gym, including their member ID number, age, and sex. The mean of the ages is 40.4, and the standard deviation is 14.3. Their ages are recorded below. Okay. Mean 40.4, standard deviation 14.3. Here are the 50 ages. Use your graphing calculator's random number generator. Ooh, cool.
Fancy.
To choose a sample of 5 gym members, use the first row of the table above as 1 to 10. Second is 11 to 20, etc. Repeat this process 3 times. Ready? I'm going to show you how to do it. It says it right there, but let's talk about it anyway just to make sure. Wow, how did that get there? Quit. Weird. Okay, so random number generator. Math. PRB, which is on the far right. And you see that we have many options. We have random integer, we have random normal, not sure what that is, random binary, things like that. Okay, we want random integer, so we want to hit number 5. Okay, some of you are getting a, what's the word I want?
List.
A list, okay, sure. If you get that, you're going to put in the same things that we are, which is very simple. We want a random integer between what and what here? 1 and 50.
50.
Well, there are 50 ages up here, right? So we want to pick one of the ages, so we want to pick one of them between 1 and 50. We will separate with a comma, so we're going to go 1, comma, 50. Oops, 50. Close the parentheses. If you have a list to fill in, the first is 1, the second is 50. Don't worry about the third. And I hit that, and there it is. There's my number. So I here got 21.
I got
So
39.
21 is the random number that I got. What is the corresponding age that goes with it? Let's see, this is up to 10, up to 20. So this is number 21, so the age was 40. With me there?
I got 39.
You are going to do that 5 times for part A. You get the corresponding ages, and then once you get the corresponding ages, you're going to find the mean of the 5 ages. Then you're going to do it again for B and again for C.
Wait.
Okay? Go.
So what are we doing?
Wait, I'm confused.
You're going to do 5 random numbers, get the corresponding ages for those numbers, and then find the mean of those 5 ages. And you're going to do it again in part B and again in part C.
So we just put the same numbers in 5 times?
No, you're going to do 5 different random numbers for A. So if I want to do it again, I want to get a second random number.
Yeah.
I just hit enter. Now I get another random number, and now I get 37.
That's what I meant.
So the second random number is 37, and I can't see what that corresponds with. Let's see. That corresponds with another 40.
So wait, what numbers did you put into the thing?
1 and 50. So 1 is the lower, 50 is the upper. And then leave the N alone.
And then so how many numbers do they want?
5.
Let's see. Got a new student in Honors Algebra 2 today.
We did?
How would you feel coming into this class brand new now?
Probably terrified.
A little rough?
I got 39 again.
As quickly as you can. We got a lot to do. If you would just hit it. Okay, go ahead. Okay, so 16 is your next one. Just hit enter. That'll make it a lot easier. If you get the same number twice in the same set of 5, skip it. But if you get the same number, in one set and then in the next set, that's okay. Is that reasonable?
I just did that, but I didn't skip the number.
Okay.
Okay.
Oh, like that.
Okay.
No. What are you doing?
What am I doing?
1 to 50.
Oh, it's the same thing?
Yep.
And then,
Enter it. Okay, so 21,
okay.
31, 24, 16, 25. 21 is 40.
I just think I got confused and it was like
Don't worry about it.
11 through 20.
Well, no, they meant that this is 1 through 10.
Oh, okay.
This is 11 through 20. So 21 is 40. 31 is 27. What's the next one? 24, 63. 16, 33. 20.
Thank you.
All right, is anybody done?
Yes.
Okay, who said that? Who was the first one to say it? Ella. I know, you're in big trouble now. I'm going to ask you for your 3 mean ages.
43.6.
43.6? 43.6. Your second one was
33.
33.
49.8.
Oh, 0.0?
No. Yeah.
And what?
49.8.
Wow. That's the biggest range that we've had today by far. No, it's random.
Yeah.
Okay, there's not bad. It's just it'll be interesting to see how those numbers play out. Okay, your numbers will be different, I assume, which is totally fine. But I just want to talk to you about what happens from here. Okay, so once you get your 3 mean ages, okay, then we want to make a mini list of just those 3. Because we're going to use that to find the mean of those 3 and the standard deviation of those three. So, a reminder of how we do that. Okay, stat, edit. I'm going to clear this out, so clear, down arrow. Whoops. That's not what I wanted to do. There we go. That's better. And so now I'm going to put in 43.6.
I got 42.6.
33.0, 49.8. So there's my list. I'm all set to go. I'll exit, I'll quit out of that. And now we're going to go stat, calc, one variable stats. Enter, enter, enter. And there it is. So, a reminder that the entire set had a mean of 40.4, I believe. Yep. And the standard deviation was 14.3. Okay? Now, that's for the original data. Okay, that's for the original data. Now, we are going to be talking about the stats for the samples. Okay, the 3 samples that we did. Okay? So the mean of those samples was 42.1. Now, the standard deviation, remember earlier we were saying that the standard deviation was sigma x, because we called that the population standard deviation. Well, at this point, we are now dealing with samples. We are finding the mean and the standard deviation of the samples that we have put together, which therefore means that for this we are going to use sample standard deviation. We're going to use this one. And our standard deviation, therefore, is 8.5. Fair? Questions on that? The mean is the mean. The standard deviation is going to be Sx this time rather than sigma x. Yep.
Why do they put it on papers?
They typically use that symbol for standard deviation, regardless. But you'll see that there is going to be like a little subscript that will help us to identify. So we'll talk about that. Okay, other questions on this? Beep. Turn the page. How does the mean of the sample means, which according to the numbers that we used was what? Nope. 42.1. The mean, okay, stay with me please. How does the mean of the sample means compare with the mean of the population? Well, in this case, ours was a little above. Did anybody get a mean for their means that was below the mean of the population? Absolutely. Anybody get means that were pretty darn close to the mean of the population? Okay? Is that weird that they would? No, because we're taking samples of numbers who have a mean of 40.4. So our samples will likely have a mean somewhere around 40.4. Some will be pretty close, some will be above, some will be below. But we shouldn't get means of 70 or 20 or things like that. What? Somebody get a mean of 20?
No, close.
What'd you get? Really? Okay. And that's pretty rare. But that's good, because we're gonna touch on that in a second. Okay? If we were to graph the sample means, in other words, the 3 that Ella came up with, the 3 that you guys all came up with, so we have 21 people in the class today, so the 63 means that we came up with. If we were to graph those 63 means, how do you think that graph would be distributed?
That's weird. Like about between 40, between the 40.4 and the first deviation has to be
So you think that the graph would be distributed how?
one outline. I mean, it's like outline.
Normally?
The most
Would that be normal? Do you think it would be, for the most part, a normal distribution? Yeah, because most of them should be somewhere around 40.4. And then occasionally you're going to have some outliers. You're going to have a 29. Okay? You're going to have a 45. Anybody have greater than 45 as a mean? Okay, but they did in other classes. In fact, one of the ones we did up here was greater than 45. So it's going to happen. But it won't happen that often, right? Which means that we'll have our outliers occasionally, and then we'll have a lot more in the center, which means that it will be distributed how? It'll be normal distribution. Okay? All right, we're going to slide down here a little bit. Okay. The histogram below shows the sample mean distribution of a class that shows a sample of 15 gym memberships rather than 5. The mean of the sample means for this data is 40.8 and the standard deviation is 3.4. Okay. So you see the notation here? This says mu, which is mean of x bar. So the mean of the x bars was 40.8, and the sigma of the x bars, so that's how they're showing that it's the sample standard deviation, was 3.4. And it looks like this. How does this mean of the means compare with the mean of the population? Pretty darn close. Pretty darn close. What happens to the standard deviation of the sample means? Standard deviation of the means as the sample size increases.
It goes down.
It goes down. Is that a logical thing that they would go down?
Yeah.
Okay. So think about this, especially if this part didn't click to you right there, which is very understandable. Let's say that we had 30 people in the class, and you guys took a test, and the average was 85%. Okay? Then let's say we decided to take samples, a group of 3, to take a sample of the class. Would you expect that the mean of that sample size, the 3 samples, do you think that the mean would be somewhere around 85?
Yes.
Could it have been? Would it be more likely to be around 85 or around 70? Really? Understood. But would it be more likely that the mean of the 3 tests that we randomly picked, would it be more likely that that mean would be somewhere around 85, or would it be more likely that those 3 people would average about 70? More like 85, because that's, well, the mean of the class is 85. So now, let's say that instead of picking 3 tests, we pick 10. What would that do if we picked 10 rather than 3? It would make it more likely that it would be closer to 85. Is that fair? The more we select out of the population, the more likely we are to get a representative sample. Not to mention, when we took 3, how likely is it for us to get outliers?
Pretty easy.
Would not be surprising. If we took 10, would it be more, less, or the same likelihood of getting outliers? Less likely, because if we take 10, again, we're taking a bigger representation, and so therefore, we're more likely to be around the mean. If we're more likely to be around the mean, then that means that the standard deviation will be lower. Better? So the bigger the sample size we take, the smaller the standard deviation. Reasonable? Logical? Cool. All right. What happens to the shape of the histogram as the sample size increases? Becomes more symmetric. Okay, I would buy that. What else? Other possibilities in there? More bell curve, which I consider more symmetric, right? I think you guys are saying the same thing. More what? I didn't hear you. More compact. So less out here and kind of more in the center. Yeah, I would agree. Do those make sense? Cool. So the sample size increases, it makes it more normal, more bell curve-like, probably more compact, less outliers and things like that. And that kind of goes along with the fact that the standard deviation is going to be smaller. Okay. So, let's talk about where we are so far. This is called a sampling distribution. Okay. The sampling, so we take lots of different samples, and then we find the stats on those samples. The mean of the means, how does the mean of the means relate to the mean of the population in general? What have we seen? Could be about the same, yes? So it should be about the same, and so that's why we're saying the mean of the means is equal to the mean of the population. That's what that means. With me there? Okay, now this is the weird one, and this is the important one right here, number 2. So make sure you're focusing on this. This says that the standard deviation of the means should be approximately equal to the standard deviation of the population divided by the square root of the sample size. Okay? It's on your paper though too. Okay? The standard deviation of the means is equal to the standard deviation of the population divided by the square root of the sample size. So, in the case of our gym members, okay, the standard deviation here should be approximately equal to the standard deviation of the population, which was